we have this question. Find the eigenvalue and eigenvector of the matrix A. Okay. So without wasting time, I'll just dive into the solution. And the first thing we need to get, step one, is to calculate eigenvalues. And to do that, we have to use this expression. To do that, the determinant of this expression equal to 0. Okay? And what is the meaning of this expression? A is your matrix. Okay? The meaning of this expression, without wasting time, is just the leading diagonal. The leading diagonal minus r. So that will be 2 minus r, then 1 minus 2 minus r equal to what? Equal to 0. Okay? Then the next thing to do is to do the evaluation for determinants so that we can get the eigenvalue. So this one times this one, that will be 2 minus r times minus 2 minus this, then minus this one times this one, that's minus 3, equal to 0. Then let's do the expansion of this one times this one, that's a minus 4, this one times this one, minus 2r, this one times this one, that's plus 2r, then plus r squared, then plus 3. This will be equal to r squared. This one we cancel out. Then we have minus 4 plus 3. That's minus 1 equal to 0. Okay, and if you look at this one, it's a difference of 2 squared. So you have this expression equal to 0. So r minus 1 is equal to 0, or r plus 1 is equal to what? Is equal to 0. So r is equal to what? 1 or minus 1. So the eigenvalues are 1 and what? And minus 1. Okay, step 2. Calculate the eigenvector. And to do that, now we use this expression. Okay, calculate the eigenvector for r equal to what? 1. Okay, we're going to get the eigenvector when r is 1 and when r is minus 1. But the first procedure to do now is to calculate the eigenvector when r is what? When r is 1. Okay, and the meaning of this one, we are going to this one. The meaning of this is just go back to your matrix. Go back to your matrix and deduct 1 from the main diagonal. Deduct 1 from your main diagonal. That's the meaning of this expression. And that will be 2 minus 1. That's 1. Minus 3. 1. This one also minus 2 minus 1. That's minus 3. Okay. Then the component of this one is the eigenvector we are looking for. The component of this will be u1 and u2 equal to what? 0, 0. Okay. Then the next thing to do is to write the augmented matrix. Augmented matrix. And then the augmented matrix will be 1, 1, minus 3, minus 3. Then you put your line, and that will be 0, 0. That's the augmented matrix. When we are doing the augmented matrix, we'll combine this one, matrix A, this one, with what? With the equal sign. And then this one will be skipped. So it's the combinations of this one and the equal values. So this is what we have. Then the next thing to do is to do the row operation. Is to do this operation whereby we want to at least one of the elements on the row 2 must be 0. That's our target. Okay, at least one of the elements in this row 2 want to make it to be 0. Okay, so row 2 now will be equal to 2 minus row 1. Because 1 minus 1 will give us 0 here. Row 2 minus row 1. And that will be equal to 1. Row 1 is not changing, it's a reference point. And this will be equal to what? 1 minus 1, that's 0. And then minus 3 minus 3. That's also what? That's also 0. 0 minus 0, that's 0. Okay, so that's what we have there. So what we now have now on the row 2, we have zeros. Okay, So we just fall back to row 1. And don't forget, the first column is at the coefficient of u1. The second column at the coefficient of what? u2. So if you want to form the expression, it will just be this one times u1, that will be u1. Then this one, minus 3 times this one, that's minus 3 u2. So u1 is equal to what? 3u2. Okay, then let's consider u2 to what? To be x. Okay, so that means the eigenvector will be equal to u1, u2. My u1 is what? My u1 is what? 3x. Okay, 3x. My u2 is what? Is x. So we can factorize this x, and that will be equal to what? 3, 1. Finally, if you take this x to be 1, then the r equal to 1, that's a 3, 1. So that's the eigenvector for r equal to 1. Okay, then the next thing to do now is to calculate also step 3, calculate for r equal to minus 1. So in doing that, we'll use our normal formula. R is minus 1. So in that case now, this becomes plus what? Plus I. And the meaning of this expression is that you come back here, and then you begin to add plus 1 to the main diagonal. Okay? And if you want to do that, just come back here, 2 minus 1 for this place. Here also, minus 2 minus 1. So which is the same thing as adding plus 1 to the leading diagonal. Plus 1 here, plus 1 here. Okay? Then that will give us 3 here, minus 3. Then 1 here also, minus 2 plus 1, that's minus 1. So that's what we have here. Then the component of this one, the u1, u2 equal to what? 0, 0. Okay? Then the next step is the augmented matrix. Okay? And that will be 3 minus 3, 1 minus 1, then 0, 0. So that's the augmented matrix. And what we are trying to achieve on this second row is to have at least one of the elements to be 0. So what we are going to do here is to multiply row 2. Row 2 will be equal to, if this can be 3, then we can take 3 minus 3. Then we can have 0, 0 here. So we can have 3 times row 2 minus row 1. So that will achieve that purpose. So that will now be, this is 3 now, minus 3 which is 0. My row 1 is not changing, 0, 0. So, and then here, times 3, that's minus 3 minus 3. So here is also what? 0, 0. So we now have now this one, 3 times u1, then minus 3 times u2 equal to 0. So this one and this one we cancel. So u1 is equal to what? u2. So just consider to be this. Okay. So finally, the second eigenvector will now be equal to, my u1 is what? So u1 is what? Is x. Okay. u2 is also what? Is x. They're both equal to each other. You can see u1 is what? u2 call it x. So u1 is x. Okay, so that's that. So we can factorize these have 1 here. Okay, if we assume this one is eigenvector for r equal to minus 1 is what? Is 1, 1. Okay, so that's that on these aspects. So if you're new on this channel, please smash that notification bell on the video.